Okay, so are we live? Hello? Hello? Welcome? Hello, hello. So, howdy. Howdy. Alright. We are here with another problem, another question to take a look at. I am interested in... I guess we'll get right into the problem. I don't have too much time. I kind of like... I have, I guess, plans later today, and I also somewhat wasted the day. I don't know. I don't want to say wasted the day, but you know, kind of meandering my way through things. So, excuse me. But anyway, so I want to take a look at this problem before I do anything else, and so let's do that. I'm gonna try to. I have to leave in about half an hour, so I don't have too much time. So we'll see how it goes. We'll see how it goes. Give it a shot. So the problem is water and jug problem. And we'll see water and jug problem. You are given two jugs with capacities X and Y liters. There is an infinite amount of water supply available. You need to determine whether it is possible to measure exactly Z liters using these two jugs. If Z liters of water is measurable, you must have Z liters of water contained within one or both buckets by the end. Okay, gotcha. Gotcha. In other words, Z liters is in one bucket, or Z liters is in another bucket, or part of Z is in one bucket and the rest of Z is in the other bucket. Fill any of the jugs completely with water, empty any of the jugs, pour water from one jug into another until the other jug is completely full. The first jug itself is empty. Famous die-hard example. 3, 5, 4, 2, 2, 6, false. Constraints. Think if they are, if the GCD is not 1, if they're co-prime, basically. Co-prime check. Is this math? I think it's a co-primality check. I don't remember though. I can't prove it. I don't remember. So GCD. Numerics. That's what I'm looking for. Okay. Let's see what happens here. Oh, excuse me. It's true, it's co-prime. I think, I could be wrong about that. Give me 1 second, I want to fix something with this browser. Okay, yeah, sometimes that happens. Let me test a bunch of cases. I don't actually know if this is right. I don't know. 3, 5, 4, 1, 2, 3. Let's just do a bunch of different numbers. One, two, three, 1, 2, 3. Oops. 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I think I got it. I don't know. Just a bunch of random stuff. We're gonna fuzz. Is this right? I kind of want to go for it. I think it might be right. I think it's that simple. Should we just go for it? I kind of want to prove it before we go for it, but I've seen this problem before. I've seen something similar. So basically, if they're co-prime, what happens is you can basically keep kind of going back and forth, and each time you do that, there will be some amount that you can reach. It's actually not correct, and the reason is, like, if you do 2, 4, and 6, no, 6, 2, and 6, 2, and 4. Oh, wait a second. How does that keep happening? You saw that? Oh, okay. It's not correct. It's not coprime. Wrong answer. There we go. Okay, yeah. Okay, good thing we didn't try it. And the reason is it's modular arithmetic, right? So what you're doing is you fill a larger cup up, 6 to 6, and you pour out some amount to give you 2. You dump 2. Pour out another amount to give you 2, and dump 2. So, and pour out 2 again. So you get 0, 2, 4, and 6. You can also get 8, right? So there's some modular arithmetic going on here. Now, what's interesting is if they are, so 6 and 2 are not coprime. If they are coprime, then also there's another issue here too. If you have, even though 3 and 5 can reach a bunch of different things, if you put like 9 in there, you can never get. So there's some special cases too. True, false, false, true. So like if z is greater than x plus y, obviously it's false, right? So z's got to be within some range of x and y. And also, if they're coprime, like 3 and 5, for instance, what you can do is you could dump 5 into 3, and you have 2. Dump 3, dump 2 into 3, fill up 5 again. Oh no. You dump 2 into 3, and now you can fill up 5 to get 7. But then you can dump 5 into 3 to get 4 and 3, still 7. Dump 3 again, dump 4 into 3, and now you have 1, and dump 3 again, now you have 1. Dump 1 into 3, now you can dump 5 and get 6. So you're able to get 7, 6, and 5. Or excuse me, yeah, 7, 6, 5, 8, 7, 6, 5. Can you get 4? You were able to get 4 when you had 1, you get 3. When you had 3, you had 3. When you had 2, you had 2. When you had 1, you had 1. You had 0, you had 0. You were able to get the full range from 0 to you were able to get the full range from 0 to x plus y. So let's say if, and I think that's true every time that the GCT is 1, you would return true, right? Let's see how far we get so far. So with this, let's just that takes care of one of these test cases. However, the one at the bottom, true, false. Oh, the otherwise I think is the issue. So you do false. Just do that for now. So yeah, so the one at the bottom though that we're missing at the bottom, the 2, 4, and 6. Okay. Now what's also interesting, if they're not coprime, so if they're coprime, basically every time you move things around, you'll always be able to manipulate your differences to get these different values until you get what you want. That's basically what I'm suggesting. If they're coprime, you could kind of always have the opportunity to do that. If they're not coprime though, then what's left over after you manipulate is it'll basically, you won't be able to reach certain numbers. So like 6 and 4 is a great example, or 6 and 2 is a good example. 6 and 4 is interesting too. So if you dump 4, you put 6, you get 2 and 4. And then if you dump 4 and then dump 2 and add 6, you still have 6 and 2, but you can't seem to get anything other than 2, 4, 6, or 8. And basically, what you're going to say is Z a multiple of, so if you take, is Z modulo this GCD, if that is a multiple of that GCD? I believe that's the answer. I could be wrong about this, but if they're co-prime, then you can get any of these numbers. However, the only numbers you can get if they're not co-prime is multiples of the GCD. That's what I want to say. Why? It's not really obvious why. It's not really obvious. I'm not sure if I could really prove it. I kind of want to go for it though. I think that's the answer. I'm tempted to just press the button. Let's go for it. Let's do it. Oh, 0, 0. Okay. All right. Well, whatever. That's kind of an edge case. Didn't really think about that one. What do you get if you do 0, 0, 0? Did they say that? Oh, they did say it has zeros. I didn't think about that. All right, I should have looked. I should have just at least tested the. It's so tempting to just go for it. I should have at least tested the like bad inputs. Yeah, if you try to do, this is a division by 0, and then GCD of 0, 0. I don't know what you get, but if X is 0 or Y is 0, then you're in a totally different ball game. I don't really know. Obviously, if Z is 0, if Z is, oh, I forgot the other one too. If Z is, no, that's fine. If X is 0 or Y is 0, greatest common divisor, both of those is 0, so. You really only have a couple of options here, right? If X is 0, then it's got to be that Y equals Z or Z is 0. Y is 0. Oh. If Y is 0, so if X is 0, Y is equal to Z, or Z is 0, Y is 0, X equals Z, or Z is 0. Something like this. Should handle this case. I don't know if you do 1, 1, 2, 3 or 4, 1. I think we got all the cases for that. 4, 1, 0, 4, zero. Yeah, I think the case with zeros is kind of tricky. I don't know if this is right. I don't know. It feels like I would need to test a bunch of the different things. I kind of want to go quick. I don't know why I want to go quick on this. I mean, I already failed it, right? Just think, are there any other test cases? Well, you kind of would want to prove this. Why does this work? It has something to do with, like, you could probably work out the math. It has something to do with, because you're using multiples of stuff, right? So if you have 5, you put in 3, right? So 5 minus 3 is 2. Modulo 5 minus 3 again would be putting 2 into 3, and then adding 5, and then putting 5, right, part of 5 into 3 gives you 4. Yeah, that's basically it, actually. It's x minus y modulo like 5, for instance, where y, it's x minus, it's let's call it k, let's call it k sub 1 minus y times k sub 2 modulo x, or alpha minus beta times x modulo y, right? And if alpha and beta are coprime, or excuse me, if x and y are coprime, then you can just cycle through all of the, you can make alpha and beta, you just keep cycling through all of the values of x. And obviously if you can go through all the values of x, then you can add y to any of those numbers to get you all the numbers between x plus y and x, all the numbers in between. Same thing if you can get, if they're not if they're coprime, you can get all the numbers. If they're not coprime, then you can only get multiples of those GCDs, of that GCD. And same thing, you can get extended further by just adding whatever, some portion of y. So, all right, let's see how we do. Oh wait, we got it. Hey, got him. All right. Yeah, I had the right idea. It's just, this is kind of a tricky question because of it's kind of a tricky question just because of like the edge cases here, and also my own like ego where I was like, oh, just 1, 2, 3, done. No. Pretty neat. I mean, you know, not bad. We got it. All right, I'll take it. I could have done so much better. It's like sad when you make a mistake on a question like this, you know, because you just feel like you sad when you make a mistake on a question like this, because it's like kind of a gimme. Like I've seen this question before, similar questions. It's kind of like it's kind of somewhat well known. Yeah, I really should have been able to do that kind of easily. You really got to be careful. I don't know, man. My ego is huge, dude. I'm too arrogant. I don't want to just like go through the tests. Like just do it. Like just go through more tests. Like look at the inputs. You know, watch for this division by 0. It wasn't even the division by 0 that caused issues. It was actually GCD of x 0 and 0, which ends up giving you a runtime error, which is strange. But yeah, division, or maybe it was the division by 0. Actually, I don't know. I don't know what GCD of 0 by 0 gives you. But we can actually just take a look right now. Excuse me. Oh, never mind. That was division by 0. That's the problem. Yeah. Yeah. When you obviously the remainder, it's the remainder after a division. So you have to divide. All right. Thank you for watching. I will go ahead and switch to another problem. Yeah, hopefully that was interesting, edifying. That was fun. I mean, I like questions like that. You know, questions like that are challenging, but I kind of already knew the answer somewhat. You know, I've seen that a few times, and yeah, that was neat. Okay, all right, moving on.